This video is for A6, equations of graphs. Now, physicists like graphs because they're useful, and the most useful graph is the straight line graph. Now, different parts of the world teach this in different ways, and we will be using the way that is taught in the United Kingdom. Y equals mx plus c, that is, m is the gradient of a graph and c is the y-intercept. This is also a popular equation for a straight line where a is the y-intercept and b is the gradient, but we will not be using that one here. Now, on this equation, whatever's plotted on the y-axis is a variable, whatever's plotted on the x-axis is a variable. And this equation has two constants. One of the constants is the y-intercept, and the other constant is the gradient of the straight line. So the equation is in the form variable equals constant times variable plus constant. And any equation that can be put into this form can produce a straight line where the constants can be extracted from the graph. The constant at the end, which is added, c, is the y-intercept, and the constant that is multiplied by the variable, m, is the gradient. Now, in A-level physics, there is a list of equations that has more than 100 equations in it that you could be asked about. You'll be given this in your exam, but it's a good idea to be familiar with them all. All of these equations can be put into the form y equals mx plus c. Sometimes this is very easy. For example, the equation c equals f lambda. On this equation, how we rearrange it depends on what we are given as variables and what we want to find as the constant. Let us assume, for example, that we wish to find what a constant wavelength is by adjusting the speed of a wave and seeing what effect that has on the wave's frequency. Bit of a weird way of doing the experiment, but let us imagine that's possible to do. So our variables are c and f, and if we were to plot c on the y-axis and f on the x-axis, you can see that lambda would be the gradient of a graph. If, however, we were given frequency and wavelength as variables, this is of course much more likely, and we have a constant speed of the wave, and we want to find what that constant speed of a wave is, well, in this case, you look at this equation and it doesn't look like it's in the same form as the equation above. But if we divide through by either f or lambda, it is. Here I have divided through by lambda. F was a variable, lambda was a variable, and therefore 1 divided by lambda is a variable, and c was a constant. And you can see that this equation is in the form y equals mx plus c, where the y-intercept is 0. We're adding 0 to this equation. So if we were to plot f on the y-axis, and the reciprocal of lambda on the x-axis, c would be the gradient. Some equations are a little bit more involved. For example, the Suvat equation s equals ut plus a half at squared. Well, let us imagine that u and a are constants. So perhaps we're doing an experiment where we are dropping something and it accelerates due to gravity, so a is constant. And perhaps we have it so we start timing how long it takes the body to descend after it's fallen a set distance. So it will pass the first timing point at a certain speed, u. That's the initial speed between those two timing points, and it is a constant. And then perhaps we change the distance between those two timing points and see the effect of the time it takes to pass between them. That means the displacement s and the time t, they're variables. And what you can see here is our equation does not look like it's in the form y equals mx plus c, or variable equals constant times variable plus constant. But it can be if we divide through by t. By dividing through by t, we get an equation like this. We know s and t are variables, therefore s divided by t is a variable. And we know t was a variable on the right-hand side. Half multiplied by a is all a constant, and u was a constant. So this equation is in the form y equals mx plus c. And in fact, if we write it this way round, it's even more clear. If we plotted s over t on the y-axis and t on the x-axis, then the gradient m would be half a, and c would be u, or the initial velocity would be the y-intercept. If we were asked to calculate the acceleration, that would be double the gradient, because the gradient is half the acceleration. Now, some of these equations could be very complicated indeed. For example, equations that have cosines in them. But that doesn't matter. You just do the same thing. You take your equation, you write it in the form variable equals constant times variable plus constant, and that will tell you what to plot on the y-axis, what to plot on the x-axis, and how you then extract those constants from that graph.